Welcome to the second part of Competency 10 quiz. In this video, we will answer questions relating to limits, derivatives, and antiderivatives. Number 5, which one of the following must have discontinuity at x equals -2, x equals 1, and x equals -3? Okay, if you recall the rules of discontinuity, it will involve the denominator, okay? The numerator is involved in other asymptotes and other situations. But we will, in order to have true discontinuity at any one of these, we have to follow through with each of these, meaning that we need to turn them into the appropriate factors. So x would be x plus 2, and then x would be -1, and then x would be plus 3. And that implies that each of these cannot equal, meaning that x cannot equal -2, and x cannot equal 1, and x cannot equal -3. And this is because they would be in the denominator, okay? So we need to look at our options. Obviously, this is not true of B and D, okay? Now, since I've laid it out in factored form, we come over here and make sure we take a look. Be careful with your positives and negatives. These are left in the given values that it really can't to be part of that rational equation, the function. It can't be as given. You have to think of it as factored together, okay, or being factored out. Okay, that being said, the only option that truly works appropriately is C. But don't take my word for it right off, okay? What you do is you take your calculator and enter it and graph it and double check it, okay? All right, so we already have a fraction set up. Oops, you arrow over and get there. Okay, so we can clear it out so we aren't messing with that. And let's put in option C and what happened and just graph it and see what we get, okay? So 2x minus the 3 and arrow down, and then put in all of those. I'm going to clear that out first. So parentheses and x plus 2, close parentheses, open parentheses, and then the x minus 1, close them, open it, and then x plus the 3 and close again. Now let's push graph. Oh, interesting. Okay, well, I mean, I can kind of gauge where these numbers are supposed to be, but I can't see everything. Okay. So here's the best thing. The best thing to do is go to the table and let's take a look at the table. Oh, well, I need to change my table settings. So second window, and I will put everything back in whole numbers because our x's are given to us in whole numbers, and looks like even though we're working with a rational, our x values are whole. Okay, so let's go down here, make this a 1. All right, now second graph. And there we go. And this tells us our y values are still in rational. They're still fractions, so that doesn't matter. We can see we have an error or a gap at 1, okay, which that's right here. So that checks out. So we need to check -2 and -3. Well, that's true about, oops, I accidentally pushed the graph. Okay, there we are. We're back. So -2 and -3 also check out. Okay, so we are correct. That is the correct option. All right, so let's look at number 6. If f of x equals x to the third minus x squared plus 1, consider the closed interval 2, 4. The intermediate value theorem would guarantee which of the following? So we need to graph this, see what it looks like, and also consider what it takes to get the slope, okay? So let's think about this. All right, so let's go back to our y equals, okay? And I'm going to arrow over and just turn that fraction off. Then come over here, and I have x caret up to the third, okay? So caret 3, and then minus x square it, yes, and then plus 1, okay? And double check, and that's correct. Let's graph this. Okay. So our mean value theorem, what does it tell us? Well, let's see here. It says what does it guarantee? Well, all it guarantees is that we're going to have at least one value of C in that interval. Okay. So, mhm. So we would have a slope here and a slope here. Okay. And we could get the value of the slope, but let's also look at our table. And let's look at 2. There's 2. When x is 2, y is 5. And when x is 4, y is 49. Okay, so that gives us reference of our y values. Well, that would be our f of x, right? Okay, so when we're considering the slope, what would we have? We would have the 49 minus the 5 over 4 minus 2. Yes, and that will give us, well, it's going to give us 22, but I think that that's irrelevant, okay? So what we have to do is read through these and see which one makes sense. Okay, for A, there is at least one C value. Yes, I've stated that. I agree. So that part is part of the definition. Where 2 is less than C and C is less than 4. Okay. Yes, that'd be here. However, such that f of C is less than 5, that will have to be in between these values. Okay? Just as this is true, that would be true here. So they're saying that f of C would be less than 5. Well, no, wouldn't it have to be between 5 and 49? And it says, or f of x is greater than 49. No, the idea is that it's in the interval and it's in between. So I disagree. Okay, let's go back to our graph. It would have to be kind of like in between if we drew our slope, if we created a slope line, okay, kind of sandwiching. So I don't agree with that one. All right, so let's go with there is no value. No, 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 no. It guarantees at least one. We don't always know which one, okay? I don't like that answer. Okay, let's look at another one. Oh, and I also don't like this. It says that uh, f of c is less than 5. That's the same as here. We disagree with that. No, it's still the same incorrect situation with the second part of the statement. Okay, let's look at C. There is at least one C value. Okay, check mark on that. Okay, where 5 is less than C and C is less than 49. Oh, I absolutely agree with that. Such that, oh no, I don't agree with that. You know why? They have this backwards. The C and the F of C. I agree with their equality or inequalities, but not with the values that they're using. So I disagree with that. Oh, I hope D is there. Okay, there is at least one value of C. I agree with that. And they have 2 is less than C, less than 4. Absolutely. Such that, yes, D is it because they're saying that 5 is less than F of C and greater than. Is that a, I think this may be a typo. Let me double check that. Yes, that's a typo. Okay, then, ooh, if that wasn't a typo, then there would have been no answer. Okay, it was backwards. All right, easy to change. Doesn't always transfer over correctly when you cut and paste. Okay, all right. So that gives us number 6. Let's go to number 7. Number 7, what is the average rate of change for k of x equals x to the third plus x minus 2? That is simply what is the slope, okay, over the interval -1 to 4. Now, if they didn't give us that interval, we could not really answer this question, okay? So anyway, what do? Put it in the calculator and look at the values. We have for our numerator, we have the values for our denominator. Okay, so that will be 4 minus the minus 1. So we know that that will be 5. So pull up our calculator and let's go to y2 and turn that one off. Then go to y3. And it's yellow. Yeah, I'll leave that color. Okay. So we have X carried up 3. We have to arrow over and then plus X minus 2 and graph. Ah, nice. But that doesn't help us very much. What we really need is second graph to get the table. Okay, so we need the values of 4 and the value of -1. So the value of 4, I'll highlight that. That is 66 minus, go up to that -1, and that is minus 4. Oh my gosh, what happened there? Oh, I see. Okay, here. Every once in a while, I'll put my hand on something and everything gets turned off. Ah, there we go. Okay, so that will be minus a minus 4. Okay, so that's 70. 66 plus 4 is 70. And that will give us 14. Okay, if you can't do that in your head, it doesn't matter. Like I said, it's always better to pop it in the calculator because when you're testing, you get tired. So 70 divided by 5 is 14. So A is the appropriate option. Okay, number 9. For the function f of g minus 4x squared plus 3, what is the equation of the tangent line at x equals 2? Okay, so for this one, what we need is to use the first derivative to find our slope at the value of 2, okay? And then we use the values of y just simply by putting the uh, equation in and reading the table, okay? All right, so we have g prime of x equals negative 8x. Well, g prime at 2, obviously, minus 8 times 2 equals negative 16. So that's our m value, okay? So we create the equation. Y minus, now we don't know what it's going to what value we're putting in yet. And that's going to equal the minus 16. And then we'll have an x and minus something in parentheses. Well, what do we know what those somethings are? We go back again to our y equals and simply, I'm going to go down, turn off that equation, and I'm using y is the 4, y4. Okay, so let's put in negative 4x squared plus the 3. And now I'm going to push enter. There we go. And graph. Ooh, I need to reset that. See what I had? I had a different graph set up. So how do we fix that? It's not a big deal. Just go down to the equation we're using, and you keep arrowing over. Now it's highlighting where we can make our changes. We push enter. Well, I'm going to change it to something brighter, snappier. How about yellow? Now, this is where it just had dots, right? So let's keep arrowing to, ooh, that's a nice solid line. This is an even thicker line. I'm going to go with that one. And then enter to your okay, enter again. Now let's graph and see what happens. There we go. That's nice and bright. However, that's all well and good, but we need the table. So second graph to get our table, and uh we need the value at 2. Okay. At 2, it's negative. Okay. So for the x, we need minus 2 because they gave us the value of x. But then we go to 2 and go over, and we have negative 3. But we have to have minus and then the negative 3. So really, a negative times a negative is a positive. So that equals, oh, I could write the right thing. So we have minus the minus, which is plus 13 equals negative 16x. Negative times negative is positive. 2 times 16 is 32. Now we need to subtract 13 from both sides, which gives us, this cancels, y equals negative 16x plus 19. Okay, and that is option C. Of course, if you're not sure about your subtraction, the numbers are getting large and you're getting tired during a test, pop those in the calculator. Don't just trust your brain. I can trust it because I have it all written down. When you're testing, use the calculator, even on the simplest things. It just saves stress and energy. And it helps with that second guessing and confidence. I know that some teachers say it shouldn't, but I don't care when I'm taking a test, especially not when you're taking your state certification. Use your calculator. It's important. I know I disagree whenever they say, oh, you should. No, 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 no. Not on something that your livelihood is hinged on. This calculator can be a major lifesaver. Okay, now let's look at number 9. If y equals x to the 5th minus 6x to the 3rd plus 4, what is the value of the first derivative with respect to x at x equals negative 1? We're going to do what we did before. If you watch the other videos with me, we will enter this into the calculator and let the calculator give us that value at negative 1. Okay, so let's do that. We have y, and I'm going to keep going and turning stuff off. I'm going to turn that off just so you can see that it's great to just keep going. But before I do that, it's set like the other one was. And yeah, what color? Let's push enter and start messing with it. Let's do something else. Light blue. Yeah, that's okay. All right, so then let's go with that nice thick line. Arrow down, push enter. Now let's go over all the way and put in our equation. Okay, so we have x carried up to the 5. We have to arrow over and then minus 6. And then we have x, and that's carried up to the 3rd. And we have to arrow over again and then plus 4. Okay, and I like to enter for good measure, give it a graph. Okay, yeah, why don't we change that color so it'll pop a little more? Let's do that. Okay, so let's go back because it just kind of blends in with the, make it that nice magenta or something. Let's see. Keep going. Nope, navy's too dark. We'd have to have the white background. Orange is nice. Let's do that. Okay, not that it really matters, but it's still fun to do. Okay, there we go. All right, I like it. Okay, so we have our graph. Now, what do? You have to say second trace because we want that blue calc. Now we are talking about derivatives, so we need 6, which they pretty much tell us what to do. So push 6. Okay, now you simply put in -1. -1. See, it shows up. That tells you you're doing it correctly. Now push enter. And right here in that orange where it says dy dx, -13. And that is option B. It's correct. Okay, this is the last question for this second video of the quiz. Again, thank you for watching. Thank you for sharing with someone that may want to watch the videos. And thank you for liking us and subscribing. Happy testing.